Here are some tips that you can use to memorize names and formulas of polyatomic ions. You really need to be familiar with these so that you can read and write formulas for ionic compounds. Okay, so most polyatomic ions are negatively charged. Okay, and their names end in either ate, ite, or ide. Okay, those whose names end in ate and ite are called oxoanions. That means they have not an element and oxygen. So two elements, one of them being oxygen. That's why it's oxoanion. So for example, nitrate is an example of an oxoanion. NO3 with a -1 charge is called nitrate. Cyanide, Cn with a -1 charge, is not an oxoanion. It's not an element and an oxygen. Okay. The only two polyatomic ions that you're likely to encounter as far as compounds are concerned, being present in compounds, are mercury 1, mercury Roman numeral 1, also known as mercurous ion. The official name is mercury Roman numeral 1, and the ammonium ion, which we already talked about. Okay, so mercury 1, you'll notice the formula for mercury 1 is not Hg plus 1. Okay. Mercury 1 is in fact a pair of mercuries. It's a diatomic ion, so its formula is Hg2 with a +2 charge. You always have to write that subscript 2. Okay? Now, why is it called mercury 1? Well, the pair as a whole has a charge of +2, so it's as if each one has a charge of +1. Okay? So they don't really have a charge of +1. The pair has a charge of +2, so it's as if each one has a charge of +1. Okay, so a better word for the +1 here is we call that the oxidation number or the oxidation state. And we'll learn more about that when we talk about redox reactions, reduction-oxidation reactions. Okay, so that's an oxidation state or oxidation number for mercury. So those Roman numerals, if you have a monatomic cation, the Roman numeral that you put there would just be the charge. It's also the oxidation number. But here's a case where the Roman numeral actually is not the charge, it's the oxidation state or oxidation number of the atoms in the polyatomic ion. Okay? Here's another tip. If you memorize the names of ions whose names end in ate, then you can easily figure out the names of those that end in ite. Okay, so for example, nitrate is NO3 with a -1. Well, change the ending to ite, you just have one less oxygen, same charge. Okay, so sulfate is SO4 -2. What would be the formula for sulfite? SO3 -2. Phosphate is PO4 -3, so phosphite is PO3 -3. Chlorate is ClO3 -1, so chlorite is? Okay, good. Now, if the formula of the ion, the formula for the ion whose name ends in begins with hypo and ends in ite, okay, will have one less oxygen than that ion that doesn't have the hypo in the name. So, for example, chlorite is ClO2 minus, okay. So this is still chlorite right here, but you put a hypo in front, you have one less oxygen. It's ClO minus. Oftentimes, this is also written as OCl minus. Same thing. So bromate is BrO3 minus. If you remember, what would bromite be? BrO2 minus, one less oxygen. And then if I put a hypo in front of bromite, the formula becomes BrO minus, BrO -1, or OBr -1. Okay. And if you have the per in front of the name of an ion whose name ends in ate, then that just has one more oxygen. It's still the same charge as the one that doesn't have the per in front. So for example, chlorate is ClO3 with a -1 charge. If you were to put a per in front, perchlorate, you now have one more oxygen. It's ClO4 -1. So if bromate is BrO3 -1, what is perbromate? BrO4 -1. If iodate is IO3 minus, periodate will be